Hi, my name's Alan Smith, and in this webcast I'm going to share my opinions on cloud computing and Microsoft Azure. The story starts when I was about 8 years old at school. I heard that IBM had developed a spell checker on one of their mainframe computers. And when I was at school, I was always terrible at writing and spelling. And I remember one of the teachers saying to me, "Alan, if you want to be able to communicate your ideas, you need to learn how to write and spell." So my answer to that was that I didn't need to learn to spell because we got computers that can check spelling. And the teacher responded, "But Alan, what if you get a job at a company and the company doesn't have a computer?" And I've kind of been ridiculing that statement for a large number of years. But cloud computing is really starting to change that. Supposing you're a restaurant manager. Now back in the 90s, if you're a restaurant manager and you wanted to manage your business, you'd drive down to the local PC store, you'd buy yourself a desktop PC with a big monitor, and you'd also buy a CD-ROM that contains bar management software. You then drive home, set everything up, and you'd be responsible for installing that software and maintaining the system. Nowadays things are very different. If you want to manage a bar, you don't really need to have a computer. This is an example of some bar management software in the US. You can see that the cash till is using an iPad that's been modified with a credit card reader and a connection to the cash drawer. And the staff in the restaurant are using iPhones. And I would argue that these are devices rather than computers. And these devices are running apps. And the software that they're running to manage the bar will be classified as software as a service. So the majority of the software that's managing this bar, and certainly all of the data, is going to be hosted somewhere else. We typically refer to that somewhere else as the cloud. So now, 45 years later, I'm actually working in the IT business, developing cloud-based systems, and some of the systems that we develop will be for customers that don't have computers. Cloud computing is all about infrastructure. This is a photo of the construction of the main Olympic Games stadium for the London 2012 Olympics. And you can see that it's a massive infrastructure project. Now I work in information technology rather than civil engineering. So I'm more at home thinking about the Olympic Games website. And if you want to host a website that's going to get significant traffic, such as the Olympic Games website, one option is you can invest a lot in infrastructure. So to host a website like the Olympic Games, you're going to need a lot of infrastructure because there's going to be a lot of demand on that website, very high capacity. You're also going to be streaming videos globally of many of the events, and in some cases these can be very, very popular. So you're going to have a lot of infrastructure, and this is going to have to be in many locations all around the world to provide performance access to all of the users. However, if we look at the load chart on the Olympic Games, you can see that the website was incredibly popular. At one point, almost getting up to 2% of the global internet traffic. However, this site was incredibly popular for a short space of time. And using traditional methods to provision a large amount of IT infrastructure to host a website with this kind of load characteristic is going to be very expensive and very challenging. So another option is to go for a cloud provider. This is a photo of one of the Microsoft Azure regions. And it was the Azure data centers, when they were in preview mode, that was used to host the video streaming of the Beijing Olympics in the summer of 2008. And this was a few months before the Azure platform was announced publicly in October of 2008. If we zoom in inside one of the server halls, you can see that they're using a container-based infrastructure. Each of these containers can contain several thousand physical servers, and it has 3 connections on it: a power connection, a network connection, and an electricity connection. Now the servers that they use within these containers are known as commodity servers. If we're going to be building a reliable server on premise, we throw money at reliability. We have redundant power supplies, redundant hard drives, redundant everything, and that gets very expensive. So we try to provide reliability through expensive hardware. The cloud providers provide availability through software. So they don't invest lots of money in very reliable servers, they use cheap commodity servers. And these servers can have a failure rate of maybe 2 or 3% per year. Now when the servers fail, they don't bother going in and fixing these servers. They just let them fail and use software to fail over onto working servers. So after a number of years, there may be a number of failed servers within those containers, but that's not a problem. They'll replace them with another container with shiny new servers in them, and these will provide much more computing capacity and consume much less power. This is an aerial view of one of the Azure regions in the US. You can see several buildings on the left of the image. And these buildings are typically known as zones, and the collection of zones and all the infrastructure surrounding it is known as a region. When you start working with virtual machines and Azure storage, you'll hear concepts like zone redundant storage and zone availability, which means that your data and services are distributed among these zones, meaning a complete failure in one of the zones isn't going to take your application offline. This is another aerial photo of the same Azure region, and you can see that they're extending this region. Now if you look at the top of this picture and then go back to the first image, it gives you an idea of the actual scale of this expansion that they're making to this particular Azure region. Now to put this into perspective, if you're a Star Wars fan, this is about the same size as an Imperial Star Destroyer. If you're not a Star Wars fan and you're familiar with the city centre of Stockholm, if we were to build this Azure region on the island of Kungsholmen, it would take up a sizable chunk of that island. It would be about a mile or 1.5 kilometres long. Cloud-based solutions can be very useful for handling different usage patterns. We've already seen the on-off or one-off pattern, which is something like the Olympics. This is a graph of the Beijing 2008 Olympic Games. So any scenario where you're going to have a big demand on the website for a short period of time, such as a marketing campaign or the launch of a new online game that's going to be very, very busy during launch week, then you may see a similar usage pattern to this. Another usage pattern is rapid growth. This is showing the load characteristic for Twitter. Before 2009, not many people were tweeting. But for some reason, at the beginning of 2009, Twitter went viral, and you can see that the load was increasing substantially. Towards the end of 2009, Twitter started experiencing some scalability problems. You can see that the load curve was dropping down, and if you were on Twitter around about that time, you may remember fail whales, which is a web page with a picture of a whale on it when the Twitter system was under heavy load, and these were quite common towards the end of 2009. However, they did manage to fix their scalability problems, and the growth of Twitter continued. Predictable burst is another fairly common load pattern. I'm a Formula 1 fan and I watch all of the races, and you can see that the website for Formula1.com is very, very popular when there is a race on. And the race calendar for Formula 1 is usually determined a long term in advance. We'll typically know towards the end of one year when the Grand Prix are going to be held for the next year. So if you had a pencil and paper, you could pretty much draw the load characteristics for Formula1.com over the next year. And if you're hosting a website that had this kind of predictable burst, you could actually schedule the scaling of your applications so that it would automatically scale based on dates and times for when the website was going to be popular. A load pattern that can be more difficult to handle is unpredictable burst. This is showing the load characteristics on the BBC site, which also hosts BBC News. And the large spikes that are occurring in 2011 are the spring uprisings which were taking place in the Middle East. With many people very active on social media, if there's a big news story that's breaking, it will be a matter of minutes before a large volume of traffic is generated on these news sites. You don't want a situation where news sites are going to fail when everybody needs them most. So with cloud-based services, we also have the capacity for applications to auto-scale, which means if there's a sudden increasing demand on that particular site or service, additional capacity and resources will automatically be added to that site to be able to meet the increase in demand. So these types of load patterns are fairly common. You may have applications that don't fall into these categories, but cloud computing can still provide great hosting capabilities for those applications. So the Four Tenets of cloud computing is something that I made up myself a few years ago. It originated from Don Box, who was one of the developers on the Windows Communication Foundation technologies. And he came up with this concept of the Four Tenets of SOA. In the early days of cloud computing, many companies had online virtualization. They were running VMware or Hyper-V, but when cloud computing started to become a buzzword, they referred to this on-premise virtualization as a private cloud. So I tend to use these four tenets of cloud computing to help define what cloud computing should offer and how it's differentiated from pure virtualization. So the first tenet is that billing is based on consumption. If you're using a cloud-based service, when you get your invoice at the end of the month, it should be based on the resources that you consume. Now this can vary a bit depending on the service that you're using in Microsoft Azure. With Azure Storage, for example, the billing really is based on what you consume. You get billed for the data that you're storing in terms of gigabytes or terabytes per month, and you get billed for the transactions that you run on the storage account. So if you create a storage account and put a very small amount of data in it and don't access that data very frequently, the bill at the end of the month is going to be a fraction of a cent. However, if you're using a service like Cosmos DB or Azure SQL Database, and you provision a database with a very small amount of data and don't make much access on that, you might find that at the end of the month you're getting quite a high bill. The reason for this is that some of the data services are billed on the actual capacity. It's based on the actual amount of capacity that's provided for you, regardless of whether or not you consume that capacity. So in an ideal world, the billing should be based on consumption, but in some cases it can be based on the provisioned capacity. The next tenet is that resources should be available on demand. If I want a virtual machine, I should be able to get a virtual machine. And the cloud provider should have sufficient capacity to be able to provide me with that resource. So when using a large cloud provider like Microsoft Azure, resources are usually available on demand. However, this isn't always the case. When Microsoft opened up 2 Azure regions in the UK, this coincided with the Brexit agreement when the UK was going to leave the European Union. So many companies in the UK wanted to move their IT infrastructure to a UK-based data centre to be out of the European Union. And this meant that these newly created Azure regions started to run out of resources. You wanted to create a server of a specific size within that region, and the resources were not available. And the COVID pandemic also affected this. When many people were working from home, there's a huge demand on the Microsoft Teams services. And that meant Microsoft had to devote many resources in their regions to be able to actually run the Teams services and all of these online services. And I remember giving training courses around about the time when we were attempting to create virtual machines in certain regions, and those machines were not available. So we had to go hunting around the world to find a region where we could find resources available. However, for the majority of the time, we should find that resources are available for us in all of the Azure regions. Another tenet is massive scalability. And this means that if I want to scale from 1 to 10 or 100 or even 1,000 virtual machines, I should be able to do this. Massive scalability is one of the advantages of using a public cloud provider. They usually have a lot of resources available, and it's very quick and easy for us to scale up our systems and provision large amounts of infrastructure when we need it. So if we're doing something like animation rendering or the batch processing of data, that's a scenario where we may need 1,000 virtual machines for a few hours to be able to complete that job. And this is very challenging to achieve using private clouds or on-premise infrastructure. And finally, cloud computing should be able to provide self-service. When we want to provision resources, we should be able to do it ourselves. We should be able to go into a portal and create those resources, or use some kind of script or command line interface, and even integrate the resource provisioning into our DevOps pipelines. And this means that we don't need to send an email to somebody or phone somebody up asking them to provision a virtual machine for us. With on-premise and private cloud, you'll find that massive scalability is not an option. And in many cases, you may find that the self-service and resources available on demand and billing and consumption are not provided either. So when we're working with public cloud providers, we'll find that they do provide all of these 4 tenets.